Okay, I'm going to go over the last sections of quarter two credit recovery. So here we go. To name figures. So for symbols, there's a bunch of different ones. You need to realize that for this, that it's a segment because it has two endpoints. So the symbol for that is just a solid bar. If this were a line and had arrows on it, the symbol for a line is this. There's lots of different symbols. And then to name it in two different ways, basically for a segment and line, you can flip-flop the endpoints. You could say segment IM, but you could also say segment MI. And that works for a segment and a line. For array, it's different. So for array, the symbol is this, which you can see I've already plugged it in and it's there and there. To name array, it's different because you have to start with the endpoint. So G is the only option to start with, but then the point it goes through is what can change. So I could call this array either GP or GN because I'm saying it goes to infinity through the other point. So that's how to name array. To name an angle in two different ways. So first of all, here is the marked angle. So that would be angle. Remember, we always kind of trace it, EDF. So EDF was the order I went in. D has to stay in the middle because that's the vertex, but I also could call it FDE. So these two endpoints of the rays, they can switch. The next one, to do an angle bisector, so this is the angle bisector section, you're going to grab this yellow dot and drag your arrow. It's going to move it back and forth. When you do that, you're going to want it so that this matches up. This will change up here, and you want to get it so that it's equal on both sides. So because 90 is divided by 2 is 45, I'm going to move that so that it becomes 45 on each side, and it will look like this. So once I have that, like I said, all of those will line up. Then you have to figure out which of these statements are true. Now these can be tricky, so I highly recommend, to read it easier, you just substitute the values in. So what I mean by that is this says measure of angle BCE, which is right here. So I would just put 45 there, and then DCE is also 45. So this is saying 1/2 of 45 is 45. Well, that's not true, so that question would be out. The next one, again, VCE, I'm going to substitute 45 in for that. BCD is 90, so this says 2 times 45 is 90. That is in fact true, so I know that that's the correct answer. It's a little bit easier to see it with numbers than with the letters, but whatever works best for you. You just have to pick which of the 4 is the true statement. Okay, and the next one, you definitely want to draw a picture. It's a really easy question once you draw a picture. So point T is on segment SU. So I'm going to start by drawing segment SU, and then I'm going to put T anywhere I want. I tend to not put it in the middle to not make myself think that it's halfway. ST is 9, TU is 7. Clearly I didn't draw this to scale, but that's okay. Determine the length of SU. So I'm hoping it's pretty obvious that you would just add, right? If I want the entire length of SU, I would just add 9 and 7 and get 16, because that would be the entire length. Same kind of situation here, but now with algebra. So we have segment MO, so I'm going to go ahead and draw MO. Point N is on it somewhere, so I'm going to put N right there. It tells me MN is X, so here's X. MO is 3X minus 6, so that's in this entire distance, so the whole thing is 3X minus 6. And then NO is X plus 1. So I'm just going to quickly color code. So I have MN here is X, and then I have NO is X plus 1. So that black and green piece add up to be the entire segment. So if I put that together, the black piece plus the green piece is equal to the entire thing. And I'm just using algebra to solve. So this is 2x plus 1 equals 3x minus 6. I would subtract 2x from both sides, just doing algebra from here. I get 1 equals x minus 6. I would then add 6 to both sides, and I'm going to end up with 7 equals x. What you have to be careful of is this is not the answer they're looking for. They asked for the length of MO, segment MO, so I would have to substitute that back in. So MO is 3x minus 6, so 3 times 7, which is what I got for x, minus 6. 21 minus 6 is 15. My final answer would be 15 for that. Next type of example is similar to what we just did, but with angles. So again, I have to label. So TUV is this entire angle, so that's 101 degrees. And then they tell me that TUW, so TUW is 60 degrees. And they're looking for WUV, which is what's left. So I'm hoping that you can see that the two pieces in red add up to be the purple. So I could set this up algebraically like this. or I could simply just understand that I'm going to have to subtract 60 from both sides. So whichever way makes more sense to you is absolutely fine. You're just going to end up needing to do 101 minus 60 to get your answer of 41 degrees. The next one, now this vocabulary word can change here. So they can give you vertical angles, they could give you complementary angles, or they could give you supplementary. So complementary angles and supplementary angles, you would set two things up, add them to equal 180 for supplementary. For complementary, you're going to add the two angles and set them equal to 90. And for vertical angles, you would set them equal because that's the relationship that vertical angles have. So in this case, I'm setting measure of angle A equal to measure of angle B. Again, if this was complementary, I would add those two up. So whatever the algebraic expressions they gave me for those angles. And then if it was supplementary, again, I would add them up and set them equal to 180. So it just depends on what the vocabulary word is for this section. And then you're going to solve algebraically. So I would subtract 3x from both sides on this. I would have 3 equals x minus 8. Then I would add 8 to both sides, end up with 11 equals x. They are looking for x this time, so I would be done after that. Now we're going to do angles with transversals. So we have a pair of parallel lines, two parallel lines here. And this is where you want to remember that pattern. So I'm going to put circles and stars, and this pattern will always exist. And what you will need to remember is anything that's the same shape, so two circles or two stars are equal, and anything that is not the same shape, so like a circle and a star, they would add to 180. So in this case, I have two angles here that are both in, these are alternate interior angles, so these would be equal, so this would be 119. But for example, if I was looking for this angle here, I would add up to 180 because this is a circle, this is a star, and with the pattern with parallel lines, you would do 180 minus 119 to get that. So those are the two types of angles you're going to see in those examples. For types of triangles, we classify by sides and we classify by angles. So there are a bunch of different words here that are going to come in to play. For sides, if you have 3 congruent sides, that's an equilateral triangle. Equilateral, there we go. If you have 2 congruent sides, that's isosceles. If you have no congruent sides, that's scalene. So that's where your first classification is going to come from. So if I'm looking at these side lengths, none are the same. So I know it's not isosceles or equilateral. It's going to be scalene. So I'm choosing between scalene acute and scalene right. For angles, we have obtuse triangles, we have acute triangles, we have equiangular triangles, and we have right triangles. Equiangular, there we go, and right. All right. A right triangle is going to have 90 degrees. I'm hoping we remember that, okay? Equiangular, they would all be the same, so 60 degrees, and that would happen if it was equilateral, so they might not even say equiangular because it's assumed. Between obtuse and acute, obtuse means it has one angle bigger than 90, and acute means all 3 angles are less than 90. So if I look at this picture, I have 40, 39, and 97, so that's an obtuse angle. So this is actually a scalene obtuse. I think I cut off 2 options on the bottom without realizing it. I think there's 2 more options on the bottom because this is a scalene obtuse triangle. So like I said, I think I just accidentally cut that off on the bottom, but that would be my final answer because all 3 sides are different and I have one obtuse angle up there. So this would be scalene obtuse. Okay, the last one is dealing with isosceles triangles. So what you want to remember is in isosceles triangles, the angles that are across from the congruent sides are equal. So this angle is also 38 degrees. And that's the one they were looking for in this case, angle OMN. So that would be my answer, 38 degrees. The other type you're going to get is when they give you one of the angles that isn't congruent. So again, these 2 base angles are the congruent ones. So I know that in a triangle I have 180 total degrees. I'm going to subtract 117 from that, and that's going to give me 63 degrees. So I know between these 2 angles I have 63 degrees. Because those angles are the same, I'm going to do 63 divided by 2 and get 31.5 degrees because again, I'm splitting what's left in the triangle by 2. So those are the 2 different types of questions you'll get with angles. And then with sides, you just need to realize that the congruent sides are opposite those base angles. So this would be 22. The 32 is irrelevant because that's the base side. It's not one of the congruent legs. And that's all the sections of quarter 2 credit recovery.